Here we have another example, so we'll jump right in. Let's use our first schematic. It includes the short part of the hypotenuse, the altitude again, and the long part of the hypotenuse. The short part of the hypotenuse is 4, the altitude is y, the altitude again is y, and the long part of the hypotenuse is 8. That allows us to write the proportion 4 over y is equal to y over 8. We cross multiply, we get y squared is equal to 4 times 8, but 8 is equal to 4 times 2. Uh, 4 times 4 is 16, so that when we take the square root of this, we're going to have y equals the square root of 16, which is 4, times the square root of 2. So there we've solved the first part of our right triangle. We now know what that altitude that's drawn in the middle of the triangle is. So once again, our first result was that y is equal to 4 times the square root of 2. So now we're going to use our second schematic diagram, which includes all of the hypotenuse, the long leg of the large right triangle, once again the long leg of the large right triangle, and then the longer part of the hypotenuse. Okay, but no, again, the hypotenuse is made of these two parts, the small part and the large part. We add them together and get the overall hypotenuse, which is 12, because 4 plus 2 is 12. The long leg is x. The long leg, once again, is x. And then the long part was 8. So that allows us to write the proportion 12. Let me write that 2 again. 12 over x is equal to x over 8. And if we cross multiply, we get x squared is equal to 12 times 8. But I'm going to write these in semi-prime factorized form. 12 is equal to 4 times 3. And 8 is equal to 4 times 2. And so that's the same thing as 16 times 6. And if we take the square root of that, we end up with our next result, which is x equals 4 times the square root of 6. And now let's use the third schematic diagram. The third schematic diagram incorporates the entire hypotenuse, the short leg of the large right triangle, again the short leg of the large right triangle, and then the short part of the hypotenuse. We know that the entire hypotenuse is 4 plus 8, which is 12. The short leg of the large right triangle is z, and then we have z again, and then the short part of the hypotenuse is 4. This allows us to write the proportion 12 over z is equal to z over 4. And we get z squared is equal to, once again, let's write this in semi-factorized form, 4 times 3 times 4 That's equal to 16 times 3. And the square root of z is z. I'm sorry, square root of z squared, pardon me. Square root of z squared is z. The square root of 16 is 4. And the square root of 3 is root 3. So we have found all three of the missing sides of this right triangle. Turned out that the altitude was 4 root 2, that's y. The long leg was 4 root 6, that's x. And the short leg was 4 root 3, that's z. And so once again, the schematic diagrams in the situation where we are using the geometric means to find the sides of right triangles, schematics are the way to go. If you do those three schematics, you get the answers very quickly.